page 67 when we're done. All right, so today's lesson is titled Geometric Mean. Mathematically, what does mean mean? Average. Okay, so the average is actually the arithmetic mean, like arithmetic. We don't usually call it that because we don't need to, because that's the only mean that you know, which goes with mean, median, mode. Geometric mean, though, is completely different. That's why you do that qualifier in front of it. Instead of being arithmetic mean, like you're used to, this is geometric mean, and it has nothing to do with an average. Okay? So, what it has to do with is similarity in right triangles. So we're going to start by looking at just that before we even talk about what geometric mean is. So we have this right triangle right here, right? And when you have a right triangle, or any triangle, you can draw the altitude in 3 different places. What's another word we use for altitude? Height. Okay, so they're actually not the exact same thing. The difference is that the altitude is the line segment itself. The height is the length of the line segment. The words are used interchangeably in word problems, but even though it's not 100% appropriate because one represents a picture, one represents a number, but still it's kind of the same thing. But with a right triangle, let's say that we were finding the area. We're not doing that, but if I did the base and the height. So on a right triangle, I could use one leg as the base and the other leg as the height, right? Or I could use this as the height and this is the base. But I could also draw in the altitude here for this to be the height. And if I did that, then line segment BA would be the base. Does that make sense? Because the altitude and the base are always perpendicular. So this is the altitude drawn to the hypotenuse. Okay? So this could be an altitude, this could be an altitude, or this could. Right? And this is the one that we're concerned with on this, in this particular case. So this says the altitude to the hypotenuse. So what that means is not just any altitude, but the altitude that we draw to the hypotenuse, like this. Okay? So the altitude to the hypotenuse of a right triangle, because you have to be a right triangle if you have a hypotenuse, forms 2 triangles. Okay, overall, how many triangles do I have in this picture? 3. So I start with this big original one. When I draw in this altitude, it creates 2 more. Okay? And then these 2 little ones are proportional. No, they are similar. Well, the things are proportional, but they are similar to each other and to the original triangle. So you end up with 3 triangles that are all similar to each other. And then all these other things start to happen. It's important, you know, it's easy to understand that they're similar, but what gets a little confusing sometimes is which parts actually correspond to each other when you're looking at this. And, you know, some people will have an easier time than others, just depending on how your brain is wired and if you can tell what's getting moved around and that sort of stuff. But at the very least, you need to be able to redraw it for yourself. So in order to do that, we're going to redraw this big triangle. I'm just going to redraw it next to it, like so. And then I'm also going to draw the medium one and the small one, where they're all turned the same way. Okay, does that make sense? Okay, you need to save that for later, dear. And in order to do that here, we're going to draw in little arcs. So I'm going to put 1 arc on B and 2 on A. That way I can kind of tell what matches up where. The big triangle. Okay, well, we're just going to pause there for a second. I'm going to give you some triangles because I wanted you to be able to kind of make sense of what's happening with these, but I didn't want y'all to cut them out yourself because you're slow and it frustrates me. So I cut them all out myself, which also means that if you mess them up, I'll hurt you. Just ask Parker. It doesn't matter. Okay, so go ahead and unclip them, and there's just one set for your table to use together. And I want you to take these 3 triangles. First of all, take the big one and turn it so it's in the same position as this one. So the big one, make it look like this. So turn it so that the line segment CA is horizontal and whatnot. Then take the 2 smaller ones and put them on top of the bigger one so it looks 100% like this with all 3 of them stacked together. And actually look at the picture when you do it. Think about where the right angle of the smaller triangles is so that you can get these stacked together. Because stacking them together isn't really even part of the activity, but man, is it difficult for some people. You may need to actually reflect the little triangles. Okay? There we go. There we go. Okay. So does everybody... So the right angle of the smaller triangles goes where on the big triangle? Look, this is the big triangle, right? The right angle of one of the smaller triangles is on the hypotenuse. Okay? And then, there we go. Okay. So now that we've got that, and you kind of understand where everything is coming from, right? So this is how we have the big triangle, and we draw in that altitude. Now, leave the big triangle there, and then take the two smaller triangles, and then put them in a row with like large, medium, small, where all the corresponding pieces are lined up. So that's all the top angles go together, all the right angles are on the left, and all the angles that are on the right are congruent to each other. Okay, you may have to reflect triangles, you may have to turn them around, but make a little triangle family. Okay, so do these two angles correspond? Okay, but you got a right angle down here. You may need to reflect the triangles. So does this angle correspond to this one? You may need to reflect the triangles. Reflect. Reflect. Take this triangle. What does it mean to reflect something? This by itself. Take this. Forget everything else. This. How do you reflect it? Bam. There you go. Okay, so there we go. Good, yeah, okay. So we got it now? There we go. Okay. So now what we have is on the big triangle, you have an arc here and two here, right? On the medium triangle, the DCA, the only angle you have labeled other than the right angle is the one with the two little marks, so it has to be here. On the tiny triangle, we have the right angle. We know where that is. And then the one with the one mark, so it goes up here. Does that make sense? You see how those all line up? Then I got to get the letters on them. So the original one, this is B, this is C, this is A. So in the second one, what letter goes, so in the medium-sized one, what letter goes on the right angle? D, and then what one is this? A, and then this is C. On the tiny triangle, what letter is the right angle? D, and then which one has the one mark? B, and then this is C. Okay. So, does that make sense how you can line them up? Notice how it was like a process and not just me trying to figure out, because see how I couldn't figure out how to turn them around and flip them around and it gets confusing. But if you have it labeled and then you take them apart and you know that you want them all turned the same way, you know what you can label where. Does that make sense to you? We're good? Okay. So, these two triangles here, are they similar to each other? Yes. By what? Angle, angle. Okay. Are these two triangles similar to each other? Yes. By angle, angle. So then are these two? Yes. By the transitive property, right? Because I could figure out the angles if I wanted to, but by what I have labeled, I can't say angle, angle. But if these two are similar and these two are similar, then these two have to be, right? So all three of them are similar to each other. Yes. Yeah, you could. Yeah, but I just wouldn't have to do all that. This takes more work and more explanation. Was that your question too? Braden, was that your question? Okay. So yeah, I could use third angle theorem and do all that, but it just takes more explanation. Okay, so now that we have it, once you have it all lined up, then it makes naming them a little bit easier. Because if the first one is ABC and it goes like this, then the rest of them all go in that same order. So this is ACD, and what would the last one be? CBD. And if you can get the similar triangles and understand how that stuff relates, you'll be able to connect this with geometric mean, no problem. Okay. Any questions at this point? Okay. So then, let's look at example 1. It says, sketch the three triangles with the angles in corresponding positions. So basically, we're going to do what we just did and then write a similarity statement. So here's my original triangle. We will put two little arcs here and one here. And then we're going to redraw large, medium, small. Yeah, mine aren't that great either. And and notice how I have them turned the same way as the original one, not the same way as the last example. And then I know this is RST. And then I'm going to give you a minute or two to get the other two labeled and the similarity statement written, and I will start you off with the first one being RST. Okay, let me get somebody to help me with this. All right, Patricia. So on the medium-sized triangle, what letter goes on the right angle? The medium-sized one. P with a question mark. All right, so then what goes here? T, good, because it has to line up with that. And then that makes this one what? S, good. Everybody okay with that? Yes? Okay, good. And then the last one, last triangle. Amy, what letter goes on the right angle? P. And then what goes here? S. And then this one is R. Everybody agree with all that? Okay? All right, good. Which triangles don't? Well, all the triangles have them. So which angles? Is that your question? Not which triangles? Okay, because in the big triangle here, all I labeled was R and T. That's it. And so when I literally cut them into two triangles, then the only angles that are labeled in the medium-sized triangle are these two, which I line up with those two. Does that make sense? Okay. All right, so then if the first one is RST, what's the second one going to be? SPT, good. And then the last one? It would be R, so it's RST, SPT, so it's going to be RPS, yeah. Okay. Yes. Yes, if you had named the first one yourself, then these could look different. That's why I gave you a name for the first one, so we wouldn't all have 1,000 different answers. It just makes it easier to talk about that way. But yes, you're right, you could have redone it. All right, anything else? We good? Okay, so there's your similarity in right triangles. Now we're going to go talk about geometric mean, and then we're going to put it together. Okay? So now we have this proportion, right? Proportions are not new to you. The pieces of the proportions should not be new to you, but I have a feeling they probably are. So when you have this, you know that a proportion is two ratios set equal to each other. But the positions of the letters or numbers or values, whatever they are, actually have a name and they mean things. So these two here that are diagonal from each other, these are called the extremes. Okay? And then these two here are called the means. Means. So you have means and extremes in a proportion. Means and extremes. So in this proportion, the means of the proportion are the same number. Notice that X shows up twice, right? And so when you have something that shows up twice like that, then that is what's called the geometric mean. And it is the geometric mean of the extremes. Okay? The geometric mean of the extremes. Uh-huh. Or both 5, or both whatever, as long as they're the same. Then it's not a geometric mean. They have to be the same, whether they're letters or numbers. Okay, so the geometric mean of two positive numbers is the positive square root of their product. So the geometric mean of A and B is the positive number. Okay, so let me just ask you this. If I have x squared equals 25, what does x equal? And -5. Thank you. I usually miss that every single time. If x squared equals 25, then x equals plus or minus 5, right? There are two answers there. But notice how the word positive is repeated over and over again. When I take the square root, when I'm solving something, I get a positive and negative. The geometric mean is always the positive number. So even though there's two answers, we drop the positive one, just like if it was a length or anything else. Okay. So the positive number is such that, well, if I cross multiply here, x times x is what? X squared. And then a times b is ab. So I just get x squared equals a times b, which also means that x equals the square root of a times b. Everybody good with that? Any questions? Good. Yes. Okay. So we're going to find just purely the geometric mean. I mean, it's going to apply to our triangles here in just a minute, but just straight up geometric mean, that means I'm going to set up a proportion. If the geometric mean is what you are looking for, then you take a variable like x, you put it in the means position twice. And then the other two spots are taken by the numbers, and it doesn't matter the order, 9 or 4 or 4 or 9. Then I cross multiply. X times x is what? X squared. 4 times 9 equals 36. Okay. So x equals what? Which is what? Good. Plus or minus 6. That's what we get for x when we solve it, right? What we want is the geometric mean. So the geometric mean then is just what? 6. Easy enough? That's it. All right, so then the geometric mean of 6 and 15, I'm going to put x in here twice, and then 6 and 15. And I'm going to give you a minute. I want you to work that one. Jacob. All right, so Jacob, I get x times x, which is x squared, equals what? 90, okay? So then x equals what? Okay, square root of 90, plus or minus, right? And then what? Are you done? Did you get stuck, or were you just not finished? Okay, but can I just leave it as the square root of 90? What's wrong with that? Can I reduce it? Yes. Okay, so Jacob, tell me what are two numbers that multiply to give me 90? 9 and 10, okay? And then 9 becomes 3 and 3. 10 becomes 5 and 2. So I end up with x equals plus or minus, what gets to come out? Wait, shh, you are not Jacob. Jacob, what comes out of the square root? We look for pairs, right? The 3's come out as just what? Just a 3, right? And then do these get to come out? They stay in there, so then you get the square root of 10, okay? No, you're looking for pairs. All right, so then geometric mean, Jacob, what is my answer? Okay, good. Okay, not plus or minus because it's only positive for the geometric mean. That's why we can't just like stop at x. Okay, so something happened a little bit earlier today that I want to make sure I address in all classes because it was really kind of a good thing that this poor little girl wouldn't let her off the hook. But she got to x squared equals 90, and then she said, then I don't know. I don't know what x is. And I said, okay, so tell me something you do know about x. So I was finally able to get her to say plus or minus. Okay, that's good. Plus or minus what? And then she just stared at me with this look of terror. You know, she was terrified that because she didn't know what to say. I said, but you can tell me something. But I don't know what the answer is. Okay, but if you're at this point, I said right here we had x squared equals 36, and you can get x equals 6, right? Yes. So we're at x squared equals 90. What do I put here? Nothing, right? And I said, you can tell me nothing. And so finally, she was able to tell me the square root of 90. But the way she said it, I know why she wasn't saying anything, is because she was trying to get to this and she couldn't. But my point was this, that the square root of 90 is the next step. And so she wasn't actually stuck yet. She was going to get stuck, which is fine. We're going to get stuck on things, but she wasn't stuck yet. She knew it was the square root of 90. The problem was she didn't know what to do after that. But if you stop here when you're really not stuck until here, you are losing points, right? Because if you can at least get to here, that shows that you understand more of it than if you stop here. Does that make sense? And then also what happens is once you get to that point and you can actually write that down, even if you already thought you were going to be stuck, sometimes just looking at what you just wrote down and you see that, then you see that, oh yeah, this is what I do next, right? So if you can learn to get, most of you don't stop when you're stuck, you stop before you're stuck, is my point. And so learn to push through and actually get to the point where you think you're stuck, and you might realize you're really not, okay? Because she knew that wasn't where she was supposed to stop, and she knew she needed to go on, but she couldn't even get to writing that down. And I know she's not the only one. I mean, that happens to a lot of you. So just make sure you're actually at the point where you're stuck. All right, any questions about that? All right, so let's just do the next one quickly so we can move on. I'm going to put the x's in there twice. This is 2 and 8. So x squared equals 16, right? So x equals what? Plus 4, minus 4. So that means that the geometric mean is 4. Okay. Everybody okay with that? So we've got similarity in right triangles. We've got geometric mean. Now we're going to put the two together. Okay. So here are some geometric means corollaries. The first one says, the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the two segments of the hypotenuse. Anybody want to explain to me what that means? No, it's a lot of words, right? Okay, so let's break this down and think about what it actually means. We're going to do that by using these blue triangles that you have, but in just a second, and setting up some proportions before we ever even go back and reread that. So on this triangle here, before we do anything else, I want you to label, we're going to put one little arc here and 2 here. And then I want you to open your blue triangles and lay them out on top of each other. And that was a big challenge, so I'm going to make you do it again. So that it looks exactly like this picture, turned the same way, like a little puzzle, all 3 triangles stacked on top of each other. Yeah, and while somebody's trying to get that done, if somebody else could clip the pink ones back together, that'd be good. So we're not scrambling to do that at the end. Did we get it this time? Good job, good job. Okay, so look, you can also match these up here with the H and the B, but the B. Look, B has to go on B, right? So reflect, reflect, reflect. Okay, so does everybody have theirs where it looks like this? Okay, so this time I don't have the vertices labeled. I have the little segments labeled. Right, H being the altitude, but H for height, even though it's the altitude. And then C is only labeled on the big one because it's not really part of the little ones. So now take the little ones off the top and make a large, medium, small little train of triangles again. Remember to reflect if necessary so that they're lined up. No, that was right, like that. Okay, but then this one's a problem. There we go. Okay, good. All right, so now we're going to redraw the little one right here, and then the medium one right here. Okay. So on my tiny one, I know that since I'm trying to turn them where they're all the same way, that little one arc has to be right there. Now, what letter goes on this leg of the tiny triangle? X, okay? This one is what? H. Y'all have the little triangle in front of you. You can use the little ones. That's why we did it. It's H. And then this one is A. Plus, look at this picture now, too, though, because you're not going to have them cut out in front of you if you need to redraw this for yourself. But in this little triangle right here, I can understand how the things can get confusing. But you know where the right angle goes. You also know where the hypotenuse of the little triangle is, too, right? And so if you just think about how this has to be the hypotenuse of it, so that's A. And then A and X are the ones that go with that angle right there. Does that make sense to you? All right, so then here's the medium one. So I know that this is my two little marks. So the hypotenuse of the medium one is what? B, because it's cross from right angle, so it's B. This leg of the medium one is what? Y, which means this leg is H. Okay, everybody okay with that? Now, we are redrawing the similar triangles so that you can understand how it relates to similar triangles and so that I can show you where these rules come from. You do not have to redraw these every single time you do one of these problems. There will be some where I tell you, redraw the triangles for me and that kind of thing, but you do not have to do it every single time. You can if it helps it make more sense to you, but we're doing it here so that we can come up with the little algebraic part that we need so we don't have to do it every time. Does that make sense? But for some people it helps to see it every time. That's up to you, but I'm definitely not going to make you do it every time. All right, so let's just look at some proportions given what we have over there. I want you to look at x in the tiny triangle, okay? So x in the tiny triangle corresponds to what in the medium triangle? H, okay? So x over h equals, and then h in the tiny triangle corresponds to what in the medium triangle? Y, okay? Everybody okay with where that came from? And notice how h shows up twice here in the means? So it's a geometric mean, right? So when I cross multiply here, this is going to give me h squared equals x times y. Anything that is a geometric mean gets squared, right? Because you multiply it, even if it was a 5, it'd be 5 squared there, right? Anything that's a geometric mean is squared. So let's look at what these words say. This says the length of the altitude to the hypotenuse. Well, in this case, the way it's labeled, this is h, right? So it's telling me h. The length of the altitude to the hypotenuse of a right triangle is the geometric mean. That means it gets squared, right? So if h is the geometric mean, I know that that is h squared. It's the geometric mean of the lengths of the two segments of the hypotenuse. So look what happens here. You have this altitude that comes through here, and see how it divides the hypotenuse into two pieces? So this is the geometric mean of these two numbers. So h squared has to equal x times y. That's what we got here just by using similar triangles. Like, we didn't use geometric mean to set this up. We just used similar triangles. It just worked out that way. Does that make sense to you? We all good so far? All right. So then let's look at x in the tiny triangle. What does it correspond to in the big triangle? A. So x over a equals, and then a in the tiny triangle over what in the big triangle? C. Okay? And again, this is in here twice, so there's my geometric mean, and it's a squared equals x times c. Okay? Now, one more before we go look at this rule. Let's look at y in the medium triangle corresponds to what in the big triangle? B. And then b in the medium triangle corresponds to what in the big triangle? C. Right? So this is going to give me b squared equals y times c. Now let's read the words that go with this. This says the length of a leg of a right triangle, which in this case it's either A or B, right? So we'll just start with A. It is the geometric mean. So if the leg, which is A, is the geometric mean, that means it gets squared. It's the geometric mean of the lengths of the hypotenuse in the segment of the hypotenuse adjacent to the leg. Okay, and I know all those words, it's confusing, but this is what this says. The leg, this is the leg of a right triangle, it's the geometric mean, so it's squared, of, now this is, I have three pieces here, the two pieces in the whole thing. It's the geometric mean of the little piece that's attached to it, which is x, and the entire hypotenuse, which is c. Everybody okay with that? Then b is the other leg. So this is a leg, same thing. It's the geometric mean of the piece of the hypotenuse that's attached to it, which is y, times the whole thing, which is c. And these are the exact same things we got just by using proportions from similar triangles. Does that make sense? You don't have to do it both. You do not have to do this every single time. That is absolutely not what I'm saying. I'm showing you where they come from and what it's saying. If it's a geometric mean, it's squared. Now notice what's happening here though. The things that get squared, it's either one of the two legs or the altitude. Those are the only things that are the geometric means. The stuff that's on the right all comes from the hypotenuse. It's either one of the two pieces or the whole thing, right? You're never going to have a leg or an altitude on the right-hand side. Legs and altitudes on the left, pieces of the hypotenuse on the right. Okay? And in the end, it's not that bad. I know at first it seems confusing and like you've got all these squares and what goes with what, that sort of thing. In the end, it's not that bad. I promise. Okay? We good? Questions? All right. So let's do examples. Now, when we go to set these up, it's not that bad if you do what I tell you to do. The people that get lost and confused don't do the steps that I tell them to do and think that they can just go do their own thing, then they get stuck and then just too bad, okay? So when we go to set these up, I look at each thing and I know that everything that has to be squared is either a leg or an altitude. So I'm going to start with this leg. This leg is z, right? It's a geometric mean. So z squared. It's equal to the piece of the hypotenuse that's attached to it, which is 2, times the entire hypotenuse, which is what? 12. Everybody with me so far? And then I stop. No, I'm not done, but I stop right here. Okay? Then I move on to the altitude. Okay, so the altitude gets squared. In this case, the altitude is x. It's equal to just the two pieces of the hypotenuse multiplied together. 2 times 10. And I stop. Then I move on to the other one. And that's the other leg. So it's squared. And it's equal to the piece that's attached to it, which is 10, times the whole thing, which is 12. And then I stop. Every time you need to set all of them up before you solve anything. Because sometimes it matters which one you start with, and sometimes it doesn't, and you don't always know when you start the problem. So if you just start doing, like some of you do, and then you get stuck because you don't have enough information, you're going to be so far into it and confused, you're not going to know how to undo it. But if you can get them all set up, then you can go back and solve them. Because if any of them, which they don't in this case, not in this first example, none of them have more than one variable, right? If they did, then I couldn't start with that one. I got to start where I only have one variable. All of them have only one variable, so it doesn't matter where I start on this particular problem. Okay, but I set them all up first. Now I'm going to come back. I'm going to start working on this one. So that means that I get z squared equals what? 24. Which means z equals, and I don't have to worry about the plus or minus here because it's a side length, and so a negative doesn't make sense, so it's only the positive one I want in the end, right? So what's the square root of 24? You got to simplify it. And you should get to the point where you don't have to do the entire tree every time. In your mind, you should be able to start breaking things up, or even if you make a tree, your tree isn't quite as lengthy. Like, what's two numbers to multiply to give me 24? Can I use, okay, can I use 4 and 6? Okay, I can use 8 and 12. Or not 8 and 12. No, I can't. I can use 8 and 3 or 2 and 12. But if I do that, now, is 4 a perfect square? Yes. And 6, it does break down to 2 and 3, but there's nothing else that can come out of that, right? So what's the square root of 4? 2. So this is just 2 square root of 6. You need to get to the point where you only have to do the tree on the really crazy numbers. You know, on the smaller ones that are kind of common, you should be able to sort of start breaking them down in your mind. Okay, so there's z. So now I can move on to x. So this gives me x squared equals 20, which means x is the square root of 20. So what does x equal? 2 square root of 5. Good. And remember, you can always check yourself. I take 2 and square it. It's 4. 4 times 5 is 20. I'm good. But you also got to make sure you have everything taken out that you possibly can. So there's x. Uh-huh. Good question. I've already answered it. Can anybody help him with that? Jacob. There you go. Right. Since they're side links, that's why it's not plus or minus. All right. So then this gives me y squared equals 120. So y is the square root of 120. Now, there's more factors to this, so making somewhat of a tree, if not an entire tree, is fine and understandable. What are two numbers here? 10 and 12 or 12 and 10? Let me give you a little hint here. When you get to a number that maybe you're not so sure of factors real easily, aren't these for sure 2 factors? Isn't this for sure 2 factors of 20? And for sure 2 factors of 24? Like, you can't tell me, because sometimes people go, I don't know, it's prime. No, you just multiplied 2 numbers to get it. How's it prime? No. I mean, they don't tell me this one's prime, but when the other numbers are obscure. All right, so 10 becomes 2 and 5. All right. This becomes what? 6 and 2. Okay, and then 2 and 3. So that means that y is equal to, good, 2 times the square root of, and then those are all singles, so they multiply back together, 30. We good with that? Any questions? Okay, the things that get squared are the legs or the altitude. The stuff on the right all comes from the hypotenuse every time. We good? All right, so we need to do the other examples. Those are something that needs to be done so that you have a better understanding of all of this. We don't have enough time to complete all those today, so we're going to start here tomorrow. You're going to work the other 2 examples. You're going to take a short quiz, and then you're going to have time just to work through these in class. Okay? We good?